All right, picking back up where we left off. This is just more notes. It's talking about vertical translation. Vertical means up and down. Vertical means up and down, and it's essentially this K. This K right here, if it's a positive one, it's moving up. If it's a negative one, it's moving down. So let's go back and see what I'm talking about here. So I'm going to ignore all those other ones down here. Check out this one at the top. See how I have that 7? It's moved up 7. Well, what if I went minus 7? Uh-oh, check it out. It went down to 7. What if I did minus 8? Check out where it is. What if I did minus 9? Check out where it goes, y'all. Okay, what if I did plus 9? There it is. Can you see the up and down nature of this? What this does, it shifts it up and down. So let's go back to this right here. Hopefully you can see the up and down nature of this. Translation, check this out. Remember, your x's always lie. So when it's a minus, normally that would be left, right, left, right, left, right, right, left, right. If this was negative and it's lying to us, that means we're going to go to the right-hand side. And this, even though it's positive, this is lying to us, we're going to go to the left-hand side. So let's go look at that. You ready to see that translation? Here we go. I'm going to leave that right there and check out this minus 3. So right now it has us sitting at a positive 3. What if I change it to that? Boom. That thing switched over to negative 3. Okay, what if I had minus 2? That is going to be, bam, positive now, because our x's lie to us. Negative 4 is the opposite. So you can see that it goes right and left whenever you do that. So the interior is the right and left transformation. This one right here is the up and down transformation. And we call them translations. So translation means it's moving, it's translating, it's moving. So going to the next page where we're going to fill out some more things. One moment. Okay, so let's go ahead and look at this example too. Function notation. F of x equals x minus 1 squared. When we say, hey, we want function notation, that means f of x. That means we want this puppy right here. If we're saying give it to me in this normal form with y's, that's fine. But if I say, hey, function notation, it means f of x. So keep that in mind. It's a lot of information. Let's look at our vertex. This is a negative, which means we're going to take the opposite. And then this is positive, and when it's on the outside, we're going to take it. Axis of symmetry, x equals 1. Transformations. Let's see. It is going to be left 1, and it's going to be, not left 1. My bad. I'm already doing it wrong. It's right 1. It's going to be right 1 times, and then it's going to go up 1. So it's up 1, right 1. Let's see if that's right. X minus 1 squared plus 3. Let's go check it out. X minus 1 plus 3. X minus 1 plus 3. Let's look at that. Cool. It went over 1 to the right. There it is. And it went up 3. And what's the normal starting position? You're like, mister, up from where? What are you talking about? From where? From here. Our normal parent function starts at 0, 0. And from 0, 0, where does it move? In this case, it went over 1 and up 3. So now that's what we have. When you're graphing these, you're going to learn to graph these by hand, more or less. Obviously, I am okay with checking your work on Desmos, but we're going to get to the point where you can do these by hand. You can see that this crosses over at 0, 4 and 2, 4 for our green one. Right there. Hold on, let me get it going. It doesn't intersect. It's okay. So basically, that's what we're going to do. I want you to graph it. When you have this down, and again, you are going to learn how to do this by hand without Desmos. But we have that point there. What's the next point we have? We have this point here, which is 0, 4, which is here. And then we can go here, and now we can go, well, obviously, look at that. Y'all, my art skills. It's like, mister, get it together. You're a math teacher. All right. Hold up. All right. Hopefully I'm back with the correct everything selected. Let me see if I can do this. Nope. As you can see, I won't be too picky on your actual pictures, but I will be looking for that. Okay. Domain. The domain is going to be all reals every time. The domain is the same all the time, all reals. I prefer notation like this. I think interval notation is my favorite. Range, you look at the y values, guys. Where are we starting on the y? And remember, y's are up and down. We're starting at 3. So it starts and includes 3, and then it goes all the way up to positive infinity. Boom. That's that. All right. That's your answers to that one. So now what I'm going to do is I'm going to go ahead and solve this one again. This is pretty easy. Here we go. One moment. Yeah, I think this is a little wonky looking to me. This right here. If this is legitimate math, I don't use it, so I'm going to rewrite this. I'm going to write this as f of x equals x plus 4 squared minus 2. So I'm going to write that. If this is something I'm supposed to teach y'all, I will learn it, but I have never seen this. I don't use that, so I'm going to write it like this. So change it to this, vertex form. So that's just the same thing, y equals, not that complicated, x plus 4 squared minus 2. That's vertex form, and of course the function form is this one right here. So vertex form is this, function form is this. So our vertex, take the opposite, negative 4, and then this stays the same right there, which is negative 2. Axis of symmetry is the x coordinate, that negative 4. And the transformations, let's see, it should be going left, it'll be going left 4, and it will be going down 2. Down 2. Left 4, down 2. Let's check it out. F of x plus 4 squared. F of x equals x plus 4, 4 squared. Plus, what was the number, y'all? Oh, minus 2. So let's put that up here, and boom. Did we do it right? It went to the left 4, and it went down 2. Good for us. Now see where it's intersecting? Some weird looking numbers right there. So it goes down left 4 and down 2, and that's where our vertex is. We'll worry about the other points of interest later, but for now we're just interested in like getting this shape up there. The domain, once again, y'all, it is all real numbers, so we're going to do it like this. Remember, infinities always have the curves. The range, find this one. This is negative 2, all the way up to positive infinity. All right, going to the next one. Oh, I don't know if y'all needed to see that more. I just clicked through it. Hold up. Yeah, if you need to pause on the screen, you can pause. 1, 2, 3, pause. All right, moving on. Yada, yada, blah, 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 this stuff right here. Okay, here's what we've got. They want us to take this graph and write this out. All right, let's give it our best shot. So I can see right here, I know immediately right now that my vertex is, let's look at this, 2, 1. 2, 1. All right? So now I have my f of x equals a times x minus h squared plus k. For now, our a is going to remain 1, so we don't have to worry about that. We're just looking at h and k today, more or less. So now, I see this right here. My vertex is 2. So I'm going to go ahead and start plugging this in. F of x, since we're not working with a, you can leave it as 1. My x stays, the minus stays. Let's look what we got here. Remember, it's going to be 2. When we have a positive number here, that's the correct one, and it's going to have the minus right there. Plus, we went up 1. And there we have it. Oh, don't forget your squared. And that's the answer. Going to this one, I see negative 1, comma, what is that? Negative 3 for my vertex. So let's go ahead and plug this in. I have f of x equals 1 for my a, because we're not doing anything with that yet, x. This minus over here is always going to go there. Minus, no matter what. Put that minus no matter what, because now you're going to plug this minus in, and it'll change it to a positive when we're done. Squared, and then that stays the same. Now clean it up. I want to see that you have every single negative where it belongs, and it will look like this. So change that negative into a positive, and you have yourself the answer. And that's that. Hold on. So I want to do this one. If the function blah, blah, blah is shifted up to the, what is the new equation? Got it. Yes, I do want to do these. I'm going to do this on another video.